All right, we're moving on into more algebra stuff so you can use some of those combining like terms and distributive property skills that we were just mastering. So take out your notes. This is Preview to Mod 6, Lesson 3, and it's solving one-step equations. My hunch is that you have done some of this before. And so it's just a matter of refreshing things in your head, as well as making sure that you've got the system or the steps and the procedure down the way I want to see your work. Okay. So we don't really have vocabulary this time, except I want to focus on this phrase and this process. Isolate the variable. Have you heard that word before? Isolate. When we're talking about it as a feeling or to describe how someone might be isolated, that means that you're all alone. Sometimes that might be good, but typically humans like to be around other people and it's not so good. But it gets to this: get alone, be alone, get everything else around you away from you. So when we say isolate the variable, I'm saying get the variable alone. How do we go about doing that? Well, you need to undo whatever math operations are happening. In other words, we're going to make use of inverse operations. Now, when you think about the operations that typically go together, adding and subtracting typically go together, and those two would be inverses of each other: add, subtract. Likewise with multiplication and division. Although I've got to tell you, I've got to stop, and we all need to stop using x for multiply, mainly because you're going to see x as a variable all the time. So I'm going to switch to using that raised dot. All right, so let's see what I'm talking about and how I want you to show your work. Every equal sign works like a balancing act, like a teeter-totter, and you can put a fulcrum underneath there and everything stays balanced. Okay, what's on the left side has the same value as the right side, and that's why they're equal like this. So what we want to do is we want to find that variable. There it is. And we want to undo what's happening to the variable. Right now, v is being decreased by 9. We're subtracting 9, or you can think of that as like adding a negative 9. We want to undo that by adding 9. And the reason I do that is because when I combine those two together, they're like terms. That goes to 0. And v plus 0 is just v. Yay! Yay, hooray. That goes away. However, if I add 9 to this side, it's going to get all out of balance and be kittywampus. We don't want that. You have to do the same thing to this side to get your final answer. I'm saying the value of v should be 7. Go back and check in the original. If v is 7, my left-hand side would look like this. And if you calculate that, you get -2. Checks. All right, next one. Here we go. I always want you to draw a line, short line, under the equal sign. Here's my variable. Right now, I've got this positive 10 sitting here that's being added. I want to get rid of it. Subtract 10 because, yay, hooray, that goes away. And I got my goal. A is by itself. However, you have to be fair and do the same thing over there. If you have siblings, I know that in your house at one point in your life, you have uttered the words, "That's not fair." You have to be fair when we do equation solving. I plugged 10 in for A right there. 10 plus 10 is 20. Okay, put a line under this one. There's my variable. I have a positive 4 here that I basically need to wipe out. You know, if you are a big gamer, you can just think that this is some sort of math game and you need to launch mathematical operations to destroy all the things that are with your variable. Make your own sound effects if it makes you feel good. B equals -3. Check it. 4 plus whatever b was. And I just said b was -3. That's 1. Boom. All right. Let's cruise and do a couple more examples here. Let's look at this first one, just because it looks a little different. Here's my variable, and I've got this -2 sitting here. Now, I know if you're focusing on this operation, I'm adding, then you would say, well, then I need to subtract -2. That looks kind of funny, doesn't it? Yes. Say yes. However, subtracting a negative really means add the opposite, add a +2. Or just simply look at this -2 and say, I got to counterattack this thing. I want it to disappear. If I lob a +2 at this side, away we go. But then you have to add 2 to this side as well to keep it balanced. And whoa, your answer is 0. Does that make sense? -2 right here plus m, which is 0. Yeah, I think it's duh. Of course it does. All right. As you get the hang of this, you'll start cruising along. I still want you to show me your work on both sides. Check with your calculator or check in your head to verify you did the right thing. Okay? All right. You keep cruising along here. Pause the video for a little bit while I keep working and check your answers on these ones. Just because there's decimals does not mean you get to cry, whine, give up, complain. None of those things. Understood? No whining allowed in math. We persist. Just because it's a decimal, no big deal. Subtract 8 2/10. Done. Make sure I see the decimal point. Check your answer. Here's one of these where I'm adding, but it's a negative value. I want that to disappear. I want it to disappear. That goes to 0. This gives me a +2/10. That checks. That goes to 0. Over here, I'm left with -9 2/10. Check it out. -9.2, subtract 7 7/10. Yes, I get 16 9/10. Oh, we can't forget about fractions. Nope. Go ahead. This wipes out and goes to 0, and n plus 0 is n. Simplify your fractions. Go ahead with your calculator if you need to and perform a check. Now, I'm just writing that because I'm going quickly, but you should also be checking and making sure you did things the correct way. I can see these are opposites and go to 0. 9 halves, and this is really another 5 halves. If I write it as an improper fraction, please don't leave things when you can simplify them as best you can and check it. On this one, add 4/7. Those are opposites. Leaves me with x plus 0 or just x. I'm going to change this into 8/14 so that I have a common denominator. Now, simplify this. I get x is 3 halves. Now, in algebra, you can leave things as an improper fraction. If it disturbs you intensely because you've been trained to write it as a mixed number or as a decimal, if you prefer, that's fine. I'm simply asking you, don't leave it like this. Get it this way. All right, now, those are just adding and subtracting examples. What about things like this? We're going to go through the same process, but this time realize that this says -4 times my variable p. To undo multiplying, we have to divide, and you need to divide by whatever is here, because a -4 divided by -4 gives you a positive 1. And positive 1 times p is simply the variable p. 1 is a number we call the identity in multiplication and division. So you have to be fair and do the same thing over there. Double check, negative 4 times my variable p, which I just said was negative 8. This one you can probably see in your head, but I want you to show me the work anyway. To get the variable by itself, I have to divide by 6. 6 divided by 6 is 1. 1 times m is m. Be fair and do the same thing over there. Check your answer. Yes, 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 6 times 5. Some of these are going to go super fast, okay? 7 divided by 7 is 1. 1 times x is x. Decimals, no problem. 2 divided by 2 is 1. 1 times w is just w. Go ahead and divide this by 2 and you should get negative 6 and 4/10. That's a decimal. Sorry, my tablet is going wonky on me today. Divide this. Make sure you divide by the negative as well, because we need to make sure that what's called the coefficient, in other words, the number in front of y, is a positive 1. Okay, so make sure that you divide by a negative to get that positive 1 in this case, and you end up with negative 4 and 5/10. Go ahead and double check it. This one, you probably would want to grab a calculator, because our point here is to solve the equation, not to double check that you can do that. That gives you 20 and 7/10. Okay? Divide. Again, watch it. Make sure you divide by negative 5 and 9/10. And thankfully, yippee skippy, this doesn't turn out so badly. You get a 1n equals 8 and 3/10. Okay? Cool. Look at the bottom ones. All of these have fractions. Fractions mean divide. So really, I'm saying some number divided by 5. You need to undo that by multiplying by 5. And since I have these written as a fraction, I'm going to write it as 5/1. Be fair and do the same thing over here. Okay? 5 in the numerator and a 5 in the denominator divide to be 1, and 1 times x is x. Yay! I isolated the variable. Multiply over here, and you should get negative 10. Check it. What's negative 10 over 5? Ta-da! Negative 2. All right, keep cranking on the rest of these. Be fair and do the same thing on each side. When you multiply by 9, you're clearing the denominator under that k so that you get a 1k. Here's my variable. I'm dividing by 2. You're counterattacking or counteracting that by multiplying by 2/1. There goes my fun clock. Ding, 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 ding. This gives you negative 18 for the variable b. Go ahead and check it. What's negative 18 over 2? Check, 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 check. I'm not going to be super picky today about you showing your check. But if you check your answers, you won't make a mistake. I can guarantee you that, because if it doesn't work, you're going to go back and redo it. Okay, all of these you need to counteract or undo by using the inverse operation, which is multiply. 3 divided by 3 is a 1x. You know, if you just want to write 1x or 1a, 1b, that's fine with me. And the last one here, we need to multiply both sides by 13. This 13 in the numerator divides with that 13 in the denominator to give me a 1R, 39. Your assignment is posted in Schoology, and it's in your packet. On your mark, get set, go, and may the force be with you.